Hey pre-calcer, I don't want to take up too much of your time, but this section has a lot to it. So let's dive into 4.1, dealing with angles and radian measures. We haven't dealt with circles before, really just logarithms in the past section. But with this section, we're going to see a lot more trig being introduced, more circles, more formulas. I hope you're ready for this. Let's start first with something that you might have seen in geometry where if we have a circle, this will get quite a bit of use in this section. If we have a circle that has a radius and there's some angle that is generated based around the center, and the circle has some radius, we can say that the length of the arc, so not quite circumference where, circumference goes all the way around, but the length of the arc, so only a smaller portion of the outside portion of the circle, can be written as S equals R times the radian measure. So now this is dealing with a radian, which is a form of a, not quite degree, but it's similar. We go back and forth between the two. But radians are another way that we can convert or talk about degrees. So if we had some circle with some radius and we had some arc length, and we might be asked to find the radian degree, the radian measure, or the radius, we could use this equation where S is the the arc, central arc, R is our radius, theta, this is theta, is the angle for the radian measure. Let's see some examples of this. I don't think these are too bad. So recall that, well, let's see, S equals R times theta, so let's make a note of that. You can kind of draw this like a pokeball of sorts. So I know that if we have S as 90, this should be equal to our radius of 15 times theta. If we go about dividing both sides by 15, super simple. We can break this down further. These are both divisible by 5s. So we could say that this is going to be 18 over 3, which we can then break down to 6. So this is saying that the radian measure equals 6 in this case. If we took this even further, well, this one doesn't really take it further. It's the same kind of idea. We have 600 equals 3 meters, so 3 times theta. Divide both sides by 3. This is claiming that our radian measure is 200 degrees. Sorry, just the radian measure is 200. Pretty simple. And so radians are new, but we also use degrees still, so that really doesn't change up too much. So in this section, we'll be going back and forth between radian measurement and degree measurement because this comes up again when we deal with more complicated trig scenarios. And I've included some instructions here for you that I'll highlight in orange. So if we wanted to convert from degrees to radians, we could convert each angle by multiplying the number of degrees by pi over 180. So I'll write this so you can actually see it. So we would take whatever the degree measurement is, multiply it with pi over 80. So let's do this here. We have 270 degrees. We're going to the radian measure. So if we have 270, multiplying this with pi over 180, you'll find yourself simplifying a lot of fractions here. So if we multiply across, we get 270 pi over 180. I know that 270 and 180 have 90 in common, which is an angle that comes up quite a bit. So I could rewrite this as 3 times 90 pi over 2 times 90. And then what can I cancel here with this fraction? Should be saying 90. So we can rewrite this as 3 pi over 2 if we were talking about the radian measurement. We can do the same for this, negative 300. Multiply it with pi over 180. These are both divisible by 60. So we could say that this is negative 5 over 3 pi. Pretty cool. So now if we were going from radians to degrees, again, we're going to use radians and degrees a lot in this section, so that's why this seems like a bit of a bland section, just talking about radians, which you haven't even really heard too much of, but they are going to be important. So we have the negative 4 pi thirds radians. And if we're going from angles in radians to degrees, we see that we multiply the radians by 180 pi. So notice that this is a bit different than the previous one. So we take negative 4/3 pi, multiply it with 180 over pi. We know we're on the right track if our pi terms cancel. That's super important. And then we have negative 4 multiplying with 180. All of this is dividing by 3. So this is eventually going to get us 240 degrees. You can use your calculator to convert this, but notice that we started with radians. We now go back to degrees, just like this. Same way, if we have 6 radians, we can multiply this with 180 over pi. 6 times 180 is 1080. So 1080 over pi degrees. I don't know what that is off the top of my head. You could use a calculator for it though.